Okay, Year 12, I'm going to go through some of the questions on simple harmonic motion, in particular ones that involve velocity in terms of displacement and ones that involve A sine theta plus B cos theta equaling the displacement and working that back into the equation. So the first one I want to look at is question 8, and you can see here, question 8, particle moving in simple harmonic motion with displacement in meters is given by that. Well, we're lucky. They tell us right from the get-go that this thing is travelling in simple harmonic motion. And they give us a value, an equation for displacement, which is x equals 2 sine 6t. Now, they tell us moving in simple harmonic motion, but they tell us to get the acceleration. Well, that's pretty easy because all I have to do is differentiate. So let's differentiate this. We know our differentiation. The derivative of sine is cos, so I'm going to get 2 cos 6t, but because I've got the 6 in there, I'm going to multiply by that 6. And again, I have to do this a second time. 6 times 2. Cos goes to negative sine, so I'm going to put a negative here, and I get sine 6t, and again, I have to multiply by what's inside. So here, I get the acceleration is minus 36 times 2 sine 6t. And we know why I didn't multiply that 2 times 36, because if I look there, 2 sine 6t, that's what x is. So I can just put x in down here, and I've actually done my proof for simple harmonic motion because I've shown that that is a differential equation. So let's move on to B now. Find the maximum speed. Well, in the differentiation process, I've found an equation for velocity, and it's there. It's that second one there. 6 times 2, it's 12 cos 6t. Now, smart people will look at this and go, well, the maximum value that cos can be, the cos of anything, the maximum it will be was 1. So my maximum velocity will be 12 times 1, which is 12 meters per second. I am going to do this another way though, because I want to be able to use this and it'll help us with C. So because it's told that it's got maximum velocity, now think when you're on the swing and someone's pushing you, when are you traveling at your fastest? You're traveling at your fastest at the bottom of the swing. So at the bottom of the swing, you're at your point of equilibrium. X equals 0, max velocity. Well, let's put x equal to 0. Remember that x was equal to 2 sine 6t. Well, 2 sine 6t equaling 0, let's divide by that 2 and we get sine 6t equals 0. Now, sine 6t, here's what it looks like. This is a graph. It goes on and on. And look at all the times it hits 0. It hits 0 here, 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 here. It's going to keep hitting 0 all the time. Now, we can find those. We should know them. But if I go inverse sine of 0, well, the times it's going to hit 0, well, is when it's at 0. And it's at pi. And it's at 2 pi. And we go on and on. Now divide by the 6. And t will equal 0. Pi on 6. 2 pi on 6. And so on. Now I have a value for t. I can put that back into the equation for velocity. And x equals 12 cos 6t. And if I put 0 in, 12 cos 6 times 0 is 0. And cos of 0 is 1. 12 meters per second. But that's only if I put the first one in. If I put the second one in, I would have got minus 1. So the velocity is plus or minus. Plus or minus 12 metres per second. Okay, let's have a look at C. Find the maximum, when will the particle be at the origin? And what will the velocity be at these times? We've just done it. That's when the particle will be at the origin. And these are the velocities. So that's a maximum velocity. And remember, if it's positive or negative, it just refers you to direction. So C's just been done. D. So just write C there. And now I'll rub this out. We'll just do D here. So D. Find the equation of the velocity of the particle in terms of x. Now, even though we know this equation from the textbook, and I did it in class, you need to be able to do it on your own. So here we go. We know the acceleration equals minus 36x. Now, we can't just integrate that to get velocity, because velocity, acceleration, and displacement are all done with respect to time. And here in this equation, it's a differential equation, and it's with respect to x. But luckily on your reference sheet, and you should know this sneaky little rule, that the half to v squared is another way of writing velocity. And it's with respect to x, which now makes this something I can integrate. So if I integrate both sides, I'll get a half v squared. And I integrate that, I'll get minus 36. I add 1 to the power, and I divide by 2, or by the power, and I get this constant, which I'm just going to write over 2 to make it easier. Now if I multiply through by 2, I'll get v squared equals minus 36x squared plus some constant. Now, I know that this is simple harmonic motion. This particle is following simple harmonic motion. So I know that v will equal 0 at the top of the swing. So imagine you're on the swing, you get to the top, you feel a bit of a free fall, a bit of a momentary stop in your velocity, and then you start heading the other direction. Well, we know that that's when x reaches its amplitude. Now, the amplitude is back in the original equation. 2. The amplitude is 2. So I go back down here. So when x equals 2, velocity is 0. So 0 equals minus 36 times 2 squared plus c. Okay, that's 4 times 36. 144. Negative 144 plus c. 144 equals c. So therefore, v squared equals minus 36x squared plus 144. Let's rewrite that the other way. 144 minus 36x squared. And that's what v squared is. Now, if we square root that, we get our velocity in terms of x. Righto. I now want to have a look at question 10. And it's a bit more complicated. So let's have a look at 10. So, question 10. Show a particle is moving according to simple harmonic motion if x equals that, and then find the maximum speed. 5 cos, okay. So, we're told that x equals 5 cos 3t plus 2 sine 3t. Now here's the key with any of these. To use the laws that we're going to use to get these things, those angles must be the same. The period must be the same. So we're going to have a go at this. So I'm going to write 5 cos 3t plus 2 sine 3t as r sine 3t plus another angle. I'm going to use the auxiliary angle. Now remember how we did this? The first thing you want to do is make your short sides. Now it's critical. If I'm going to write that as sine, I need this 5 to be a sine angle. Right? I need it. Oh, sorry. If I'm going to write it as sine, I needed to write it. This is a cos angle. So I'm going to put the 5 here. I'm going to put the 2 here. I'm going to square them, add them, and square root them. That's going to be 29. And I'm going to put my little alpha in here. So x equals 5 on 5 cos 3t plus 2 sine 3t. Now, I'm going to multiply by root 29 and divide everything by root 29. It doesn't change anything because I've multiplied top and bottom. Okay, so I've got root 29 and I've got 5 on 29. Now in terms of this alpha, that's cos alpha, and I've got cos 3t. And this is, in terms of alpha, sine alpha. Sine alpha, sine 3t. Now it's important here to get your 3t first. So because I'm multiplying, it doesn't matter. So I'm going to write the cos 3t, then the cos alpha. And I'm going to write the sine 3t, and then the sine alpha. And now it looks like the formula that I want to use, which is cos cos, sine sine. Now I did say I was going to use r sine theta, but I'm not. I'm going to use r cos theta. My r is my 29, or root 29, and this is cos 3t. Now, I wonder what that plus does. Oh, I'm lucky. It's on my formula sheet, and it's going to be minus alpha. Now, I've got this lovely equation, which I can then, and what was I doing with this question? I was showing that it was simple harmonic motion. Show that it follows simple harmonic motion. So I've just rewritten that as a single wave functions. So now I'm going to differentiate. Well, remember that alpha is a constant. I'm going to find out what it is over here in a minute. I'm going to find out what it is in a minute. So at the moment, it's just a number. So when I differentiate, well, I've got root 29. And I go here, sine, cos, sine, cos, sine, cos, and negative, negative. And I go, the derivative of cos is negative sine, so I'm going to put a negative out the front. I've got this cos 3t minus alpha, and you can see now why I didn't want the negative in the other way around. And I've got a 3, so I've got to put a 3 there. Let's differentiate again. And the derivative, it should be sine. The derivative of sine is cos. So I've still got the negative 3. I've got my root 29. And I get cos 3t minus alpha. Nothing happens to the alpha because it's constant. But I've got to multiply by 3 again. So it gives me minus 9 root 29 cos 3t minus alpha. And look at this. That's what x is. So acceleration equals minus 9x, hence simple harmonic motion because it's in that differential equation. And straight away we know what the period is. The period is 2 pi on the square root of 9, which is 3. Okay. We have to find the maximum, did it say maximum acceleration or maximum speed? Find the maximum speed. So the maximum speed, so B, the maximum speed is when x equals 0. Now, I could go and do it here. And I could look at the amplitude and do it that way. Or I can find when this equation of x equals 0, find the time and sub it in. I've got 2 options here. I'm going to go this time, rather than get my half to v squared and take the acceleration, integrate it, add the c and do all that, what I'm going to do is I'm just going to find when x is 0. So when x is 0, root 29 cos 3t minus alpha equals 0. Divide by the root 29. Cos 3t minus alpha equals 0. Now the cos curve goes like this. Now I'm going to get a 0 there, I'm going to get a 0 there, and it's going to continue. So 3t minus alpha is going to equal 0 at these points. Well, that's pi on 2. And that's 3 pi on 2. And it's going to repeat. And because we're only finding the maximum speed, we only need one of these. Now, you're thinking, I better find out what this value is. I better find out what alpha is and t is. And you don't have to. Because remember that the velocity is written as 3t minus alpha. So, as Carl Friedrich Gauss did, don't do more work than you have to. So the velocity will be when 3t minus alpha is pi on 2. And 3t on alpha is what I've got to put in. And it's minus 3 times root 29 times cos pi on 2. Sorry, sine pi on 2. Which is minus 3 times root 29. which is negative 16.2. But if I'd used the 3 pi on 2, what do you think would have happened? I would have got minus 3 root 29 times negative 1, and I would have got positive 16.2. And that makes sense. Now, before you even go in and jump in here, you didn't even need to do all that. You know that this velocity will be a maximum. Well, the maximum value of sine of anything is plus 1 and minus 1. That's their maximums. So you could have just basically said, oh, okay, it's going to be when that is plus or minus 1. They're the maximums. You would have got it. But the mathematics is important. Anyway, that's question 8 and 10, one that requires you to use your half to v squared dx and get velocity in terms of x, and the other one uses the r sine or the auxiliary angle. All right?